NASA just changed everything for SpaceX's moon landing. NASA just made a decision that changes everything about how we're going back to the moon. On February 27, 2026, Administrator Jared Isaacman stood before the press and announced a complete restructuring of the Artemis program. The mission we've been calling Artemis 3 for years will no longer land on the lunar surface. This isn't a minor schedule adjustment, it's a fundamental shift in strategy that reveals something crucial about the challenges SpaceX has been facing with Starship, and what it means for America's race to return to the moon before China gets there first. If you follow space closely, this is a story you'll want to understand fully. So stick around, and if you're new here at Infinite Approach, consider subscribing so you don't miss what comes next. The original plan was straightforward. Artemis 2 would send astronauts around the moon in 2027, then Artemis 3 would follow and land on the surface in 2028, using SpaceX's Starship as the human landing system. One mission to orbit, then straight to the surface. But 2 days before NASA's announcement, the Aerospace Safety Advisory Panel released a report that changed the calculus entirely. They stated the original plan did not have proper safety margins and was not realistically achievable. What NASA announced instead represents a dramatically more cautious approach. Artemis 3 will still launch in 2027, but astronauts won't go anywhere near the moon. Instead, they'll stay in low Earth orbit and practice docking with the lunar landers being developed by SpaceX and Blue Origin. The actual moon landing has been pushed to Artemis 4 in 2028, and NASA is now pursuing 2 potential lunar landings that same year. Think of it as adding a dress rehearsal before opening night. Isaacman explained that the thinking was to ensure each mission builds incrementally on the last, advancing capability without taking on more risk than necessary. He pointed to history, noting that we didn't go right to Apollo 11. There was Mercury, Gemini, and multiple Apollo missions before the first landing. His argument was that Artemis had been structured to skip those intermediate steps, and that approach was setting the program up for failure. So what prompted this dramatic pivot? The answer lies in the staggering complexity of what SpaceX is attempting with Starship. When NASA awarded SpaceX the contract in April 2021 for $2.89 billion, they were betting on an architecture unlike anything attempted in the history of spaceflight. Starship stands about 165 feet tall, roughly the height of a 15-story building. It was designed originally for Mars missions, not as a small lunar module like Apollo used. Getting something that enormous to the moon requires a choreography of launches that sounds almost absurd when you first hear about it. The Starship lunar lander can't reach the moon on its own fuel supply. It needs to refuel in Earth orbit first. To accomplish this, SpaceX must launch a propellant depot into orbit, then send up somewhere between 10 and 15 separate tanker flights in rapid succession to fill it. These tankers carry cryogenic liquid methane and liquid oxygen that must be transferred without boiling off in the vacuum of space. The fuel must stay hundreds of degrees below zero, while the sun bakes one side of the spacecraft to over 120 degrees Celsius, and the shadow side plunges to negative 150. Only after this orbital gas station is fully stocked can the lunar Starship refuel and head to the moon. Nobody has ever attempted anything remotely close to this at scale. During their third integrated flight test in March 2024, SpaceX successfully transferred about 5 metric tons of liquid oxygen between internal tanks on the same vehicle. That was a crucial first step, but Starship's total fuel capacity is 1,500 metric tons. That test represented less than 1% of what's required for a lunar mission, and transferring fuel within one vehicle is categorically different from transferring it between 2 separate spacecraft that must dock, maintain connection, and coordinate complex fluid dynamics while hurtling around Earth at 27,000 kilometers per hour. The Aerospace Safety Advisory Panel identified this as a critical concern. Their report noted that programmatic and technical risks have continued to emerge, especially with the human landing system, given its intricate operational design and complex concept of operations. In plain terms, SpaceX is behind on critical milestones, and the original timeline was forcing too many untested procedures into a single mission carrying human lives. NASA's Office of Inspector General had warned back in 2021 that the timeline was unrealistic. Major spaceflight programs historically take 8.5 years from contract award to operational flight. SpaceX was attempting it in roughly half that time. The Apollo lunar lander took 6 years with substantially higher funding adjusted for inflation. Based on those benchmarks, the OIG estimated potential delays of 3.4 years. So what happens next? This is where it gets really interesting, and if you're finding this breakdown useful, a quick subscribe helps us keep covering these stories in depth. NASA has essentially placed two competing bets. The revised Artemis 3 in 2027 becomes a dress rehearsal in Earth orbit. Astronauts will dock with either SpaceX's Starship, Blue Origin's Blue Moon lander, or potentially both. They'll test communications, life support integration, navigation systems, and the physical act of transferring crew between vehicles. It's a full shakedown cruise in the relative safety of low Earth orbit, where problems aren't fatal. Then comes 2028. NASA is targeting not one but two lunar landings that year, designated Artemis 4 and 5. Whichever company demonstrates readiness first gets the mission. If both prove capable, each handles one landing. This competitive pressure is deliberate. Isaacman made it clear that the first company capable of safely delivering American astronauts to the lunar surface and back is the one America will fly with. Blue Origin received $3.4 billion in May 2023 to develop their Blue Moon lander. Unlike Starship, Blue Moon uses a more conventional architecture, launching aboard Blue Origin's New Glenn rocket, which completed its first test flight earlier this year. They've paused suborbital space tourism for at least 2 years to accelerate lunar development, and they're aiming for an uncrewed demonstration landing potentially this year. SpaceX has completed 11 Starship test flights with varying degrees of success. They've caught and reused super heavy boosters, demonstrated controlled atmospheric re-entry, and produced over 600 Raptor engines. The Block 3 variant launching April 7th aims for higher payload capacity that could reduce the number of tanker flights needed. But orbital refueling at scale remains the elephant in the room, and every month without a successful demonstration pushes the timeline further right. And then there's the geopolitical dimension that makes these delays even more consequential. China isn't waiting. Their Mengzhou spacecraft and Lanyu lander are scheduled to launch on Long March 10 rockets, targeting a lunar landing by 2030 and possibly as early as 2028. They've already returned lunar samples, landed rovers on the far side of the moon, and are methodically assembling the hardware they need. Former acting NASA Administrator Sean Duffy publicly stated that Starship delays risk letting China reach the lunar surface first. He openly questioned whether Blue Origin could get the job done faster, which is NASA publicly questioning whether they bet on the right horse. SpaceX's approach to these challenges follows their typical pattern: rapid iteration through failure. Build it, fly it, watch it explode, learn, build another. This works remarkably well for developing new technology. Starship has progressed faster than traditional aerospace programs precisely because SpaceX accepts spectacular failures as part of the learning process. But it creates tension with NASA's need for predictable schedules and risk-averse operations when human lives are involved. The question is whether SpaceX can transition from rapid prototyping to operational reliability fast enough for NASA's timeline. The fundamental question isn't whether humans will return to the moon. They will. It's whether the architecture we've chosen can deliver on the timeline we've promised, and whether the incremental approach now being adopted represents wisdom or an admission that we overreached. By 2028, one way or another, we'll have our answer. The race is no longer just against technical challenges. It's against geopolitical rivals and the limits of what commercial spaceflight can achieve when national prestige hangs in the balance. We'll be tracking every development as it unfolds here on Infinite Approach. If you want to stay ahead of the story, subscribe and hit the bell so you're the first to know when something changes. Thanks for watching.